Good day, everyone. We will now discuss sum or difference of two cubes or SDTC. Based from our previous discussion, here are the steps once again on how to factor polynomials. For second step, we will always look at the number of terms of the polynomial. If it is a binomial, you have two options, DOTS or SDTC. The question now is, how will you know that you should use sum or difference of two cubes or SDTC? So look at the following examples. Here on the left part of our screen, we were asked to find the product. And here on the right side of our screen, we are asked to find the factor of the following given. So based from our discussion before, factoring is just the reverse of finding the product. So notice that the answer here is also the given here as well on the right side of our screen. Here, it's the same given here. And here, 8y cubed plus 1, it's also the given here when we were asked to factor. So in other words, the answer here is just the reverse of the given table on the left. That's the quantity of a plus b times the quantity of a squared minus ab plus b squared. Here is a minus b times the quantity of a squared plus ab plus b squared. And the last one is 2y plus 1 times the quantity of 4y squared minus 2y plus 1. The question now is, how do we know if you can use SDTC? I want you to pause this video and look at the pattern here on our right table. Look at the similarity between the three givens and figure out as well how will we get the answer even for the span of 10 seconds. By now, you should be able to have your personal observation. So perhaps the first thing that you will notice, all of them, the three given here are all binomial. So the given here is a binomial. This is also a binomial. This is also a binomial. The first terms of each given are all perfect cubes. How do we know if it is a perfect cube? If you can multiply a factor by itself 3 times. So for example, for a cube, it is a perfect cube because you can multiply a by itself 3 times. How about ay cube? You can also think of 2y for that. If you multiply 2y by itself 3 times, you will get 8y cubed. What else do we notice? The second terms are also perfect cubes if you notice. Okay, b cubed is b times b times b. Well, 1 is 1 times 1 times 1. So that's how you will determine whether SDTC is applicable or not. So it's so-called as sum or difference because it can be either plus or a minus. So now, if that is the if that's how we determine whether we can use SDTC, the question now is, how do we get the answer right away, even if we're just given with 10 seconds? Okay, so if you notice here as well, the first polynomial provided to us in each of our answer in here, they're all binomial. And the other one is a trinomial. So that would always be the pattern. It would be a factor of a binomial. The factors would be a binomial and a trinomial. So the question is, how do we get the binomial? So the first term here is actually the square root of the first term. So the the cube root, the cube root of a cube is a. So that's a in here. How about the second term? That would be the cube root of the second term, b cube. So that would be b. How do we know that it is a plus? Okay, you will just have to copy the operation in our given, which is a plus. Okay, is that true to the others? Let's check. For example, we have 8y cubed. If you get its cube root, you will be getting 2y. The operation is a plus in our given. The operation as well in our answer is a plus. And the second term is a 1. If you get its cube root, that would also be 1. So that's how you will get the binomial of our answer. How about the trinomial? You have to pay attention to your binomial because that's how you will determine the result in our trinomial. So for a squared, it is just the square of the first term of your binomial. So take note, yung first term natin dito, a. So you'll get a squared. Here, it's also a. The square, the square of an a is a squared. The first term here is 2y. That's the square of 2y. That's 4y squared. Because 2 times 2, 4. Y times y is y squared. Very good. How about the operation? So the operation is always the opposite of the operation between your terms in the binomial. So here it's plus. So that means here it must be minus. Here it is minus. So this must be a plus. This is a plus. So that means it must be a minus. Okay, so I hope that you get the first and the operation next to it. Down to the second term. How do we get AB? So the second term is just the product of your first term in the binomial and the second term of your binomial. So A times B, you'll get AB. And here, let's proceed to the third one. 2y and 1. So 2y, first term times the second term, 1. 2y times 1, you'll get 2y. Okay. What's the operation next to it? It is always plus. So no matter what you do, it's always a plus. So unlike our previous operation, it must be the opposite. But here, it's always a plus for our third term. Finally, for our last term, how do we get the result? It's just the square of the second term of our binomial. So what's the square of b? B times b, b squared. It's the square of b squared again. Second term here in the binomial is 1. What's the square of 1? 1 times 1 is 1. So there you go. That will give us the idea on what is our rule when we use SDTC. So all you need to remember, first, it must be a binomial. Next, the first and the second term of the given must be a perfect cube. So it doesn't matter whether the operation between the two terms would be a plus or a minus. Next, how do we get the answer? So the answer is always a binomial times a trinomial. So the binomial, you just have to get the cube root of our first term, a cube, which is a. Just copy the sign of the given or the operation in the given plus. And next is the cube root of b cubed. So which is a b. Same here, same pattern, so a minus b. How do we get the trinomial? First, get the square of the first term. Here, always opposite. So plus, this is minus. This is minus, this is plus. Next is you get the product of the first and the second term. So A times B, AB. A times B, AB. Next is always plus. And finally, the square of the second term, B times B is B squared. Let's have an example. We have here x cubed minus y cubed. So the first step is always to check whether there is a GCF, but there's no GCF. So we will proceed to the second step. So do we have two terms? Yes, the first term is x cubed, second term is y cubed. And then we determine whether it's DOTS or SDTC. So it's not DOTS because the first term is not a perfect square. When we say perfect square, it must be x times x. Then you'll get x squared. But it's x cubed, so it's not dots. Perhaps you proceed to SDTC to verify whether it's a perfect cube. So x cubed is a perfect cube because x times x times x is x cubed. So it's a perfect cube. How about the second term? That's y times y times y. So it's also a perfect cube. So in other words, you can use SDTC here. For you to find out what's the answer, so you must think that there must be a binomial and there's a trinomial. So first, in our binomial, just copy the operation minus. Get the cube root of x cubed, in which it's x. So x. Second term, get the cube root of y, so y. Next, in our trinomial, so if this is the first term, you get its square. Next is to get the opposite of minus. The opposite of minus is plus. Then, whatever is your first and second term in our binomial, you get its product. So, x times y, so xy. Always positive. And lastly, the second term, you get its square. So, the square of y is y squared. There you go. The answer is the quantity of x minus y times the quantity of x squared plus xy plus y squared. Let's proceed to our example 2. 8y cubed plus 1. Same pattern, same flow. First is to figure out whether there is a GCF or not. There's no GCF, that means we should proceed to second step. Second step, identify the number of terms. There are two terms, 8y cubed and 1. Is it TOTS? No, because 8 is not a perfect square. 8 is 2 times 2 times 2, not just 2 times 2. How about SDTC? Let's verify. First term is 8y cubed. 8 is 2 times 2 times 2. That's right, it's a perfect cube. Y cubed is y times y times y. How about 1? That's 1 times 1 times 1. So therefore, you can use SDTC in here. So the answer is always binomial times a trinomial. To get the binomial, get the cube root of the first term. Cube root of 8 is 2. Cube root of y cubed is y. Always copy the sign or the operation plus. Second term, you get its cube root. The cube root is 1. To get the trinomial, you have to get the square of the first term. So the square of the first term, 2y squared. Then, the operation in the binomial is a plus. Always get its opposite, minus. Then get the product of the first term and the second term. That's 2y times 1. Then always plus. Then get the square of the second term, then you just simplify it. 2y plus 1. The square of 2y is 4y squared. The product of 2y and 1 is 2y. The square of 1 is 1. So there you go. Let's proceed to C. The given now is 64 a to the power 4b minus ab to the power of 4. Okay, always remember, the first step is always to find the GCF and factor it out. So based on the given, you will notice that it has a GCF. What's a GCF? Both terms has an a with it. So automatically, you have to pull out the a or factor it out. How about the b? Both of them has b with it. So there's one b in the first term. There are 4 b's in the second term. So you just have to factor out 1. If we factor out the AB, so that will mean that will be 64. Since we factored out one of the A's, what will be left here is just A cubed. The B here in the first term, since we factored out the B, so there will be no B's anymore in our first term. How about in the second term? It's AB to the power 4. We factored out the A, remember? So that means there will be no A anymore in the second term. How about in our b to the power 4? Since we factored out one of the b's out of the 4 b's in here, so that would just be b cubed. Okay, now you have to figure out whether you can still factor it out or not anymore. Second step is to identify the number of terms left. So there are 2 terms. Okay, if there are 2 terms, your option would just be DOTS or SDTC. Is it DOTS? No, because 64 is not a perfect square. How about SDTC? 64 is a perfect cube because 64 is 4 times 4 times 4. How about A cube? That's A times A times A. So yes. How about B cube? That's B times B times B. So you can factor it out using SDTC. Using SDTC, if you factor this out, binomial times a trinomial, you get the cube root of the first term. Cube root of 64 is 4. Cube root of a cube is a. Copy the sign for the operation. That would be a minus. Cube root of b cubed is b. Now, for the trinomial, all you need to do is to get the square of the first term. This is a minus. It must be the opposite. Get the product of the first and the second term. So 4a times b. Always a plus. Then get the square of the last term, or the second term in it. Then simplify. So that would be ab times the quantity of 4a minus b. The square of 4a squared, meaning you have to multiply 4a by itself twice. So 4 times 4, 16. A times a is a squared. 4a times b is 4ab plus b squared. So there you go. This is our final answer. For our next video, we will be talking about what will we do if the given polynomial is a trinomial. So how do we factor out trinomials? So one option is perfect square trinomial. So thank you so much.